Okay, I'd like to go over the key for the gas laws quiz. This would be for Form A. All right, so in the first problem, if you read through the question, one thing you'll notice is that, or should notice, is that there's no mention of anything that would indicate that a change is occurring. There's no first, final, initial, changed from this to this. We're just talking about a sample of gas, so the appropriate equation would be PV equals nRT. All right, and it asks us what the temperature is, so we need to get T by itself. Rearranging to get T by itself, we get this equation right here. We plug in all of our values, and notice that the R value that we use, this one right here, we choose that because our pressure is given in millimeters of mercury, so we choose the R value that contains millimeters of mercury as its pressure, and we end up getting 152 Kelvin. All right, notice that we round this to 3 sig figs because all of the numbers in the problem have 3 significant figures. So the one with the least number of sig figs is 3. What would happen to the final pressure if the volume was halved? All right, remember, if it says change things and how it affects some other parameter, you assume that everything that's not mentioned stays the same. All right, so we're going to have the volume. Well, what was the volume? The volume was 30.4, so the new volume V2 is going to be 15.2, which is half of the original volume, which is 30.4. What was the original pressure? We can pluck that out of the first equation. It's 672 millimeters of mercury. And what's the final pressure going to be? All right, we rearrange to get P2 by itself, plug in the values, and again, we round it to 3 significant figures because we've got 3 sig figs, 3 sig figs, 3 sig figs. That means the answer should have 3 sig figs. All right, the next one. All right, going through this problem right here, do we have change going on? Yes, increased. That's the change word. Also, you notice that we have moles in there twice, meaning there's indicating that there's a original number of moles and a later number of moles. All right, N is the variable for moles. It says calculate the final volume. That's V2. So we could use this equation right here, which is the standard form for any time you have a direct relationship. We need to get V2 by itself. So we first cross multiply to get rid of the fraction. That gives us what's on top here. Then to get V2 by itself, we're going to divide both sides by N1. Gives us this equation right here. We plug in what we know, and again, if you take a look at the number sig figs, this would have 3 sig figs in the final answer. All right, so this one right here, number 3, it says blah blah blah. What would the volume be of this balloon at STP? All right, remember, STP stands for standard temperature and pressure. All right, it's a special temperature and a special pressure designed to mimic the type of conditions that we live our life in, which is about the same temperature and about the same pressure. So this new temperature is going to be 273 Kelvin, which is standard temperature, and the new pressure is going to be this right here. And why did we choose the standard pressure in kilopascals? Because if you look at the original pressure we were given, it was in kPa. So we want to choose units that match the units that we already are dealing with. All right, so we've got this equation right here, P1V1 over T1 equals P2V2 over T2. Rearranging to get V2 by itself, we get this equation right here, plugging things in. We give an answer right here, and you'll notice here, which of these numbers has the fewest number of sig figs? We actually have one that's got 4 sig figs, but we also have one that's got 2 sig figs. All right, everything else has 3. The number of sig figs in your answer is given by the thing in the equation that has the fewest number of sig figs. All right, as long as you're multiplying or dividing. All right, so that's why this is 190 liters. All right, number 4 is just a partial pressure problem. The sum of the partial pressures will add up to the total pressure. So if you take your total and you subtract away the partial pressures of the gases that are mentioned. It should give you the partial pressure of the gas which is not mentioned. All right. In this case with sig figs, this is addition subtraction. So therefore, it should be rounded at the position of the number in the calculation that has the furthest left position of uncertainty. Here, that is the thousandths position. Here, it's the 10,000ths position. Here, it would be the thousandth position. So the thousandths position is the furthest left of all those positions. All right. So when we get this answer, we need to round it at the thousandths position, which would be 0.148 atmospheres. All right. Question 5. What is the pressure in kPa exerted by this? All right. Notice there is no mention of change going on. All right. So this is a PV equals nRT. We get the pressure by itself. Notice that the R value that we get, we choose because it asks us to get our answer in kPa. So we choose the one that's got kPa, and we round our number to 3 sig figs, which gives us this right here. Okay, so one last one would be, what would happen if to the final pressure if the final temperature was tripled? All right, so what happens if we take, a good question would be, should we triple the Celsius temperature or should we triple the Kelvin temperature? Well, remember what temperature is. It's an indication of the amount of motion that that the particles have. In which form gives you the actual indication of that amount of motion. It's the Kelvin temperature. So that would be the one that would make sense to triple. All right. So we get 945 Kelvin. That's our T2. Our original temperature was 315. Our original pressure was 138. We got that from our solution here. What's going to be the new pressure? So we take the equation right here. We rearrange to get P2 by itself. Plug in, and it's kind of off the screen, but it says the pressure is going to be 414 kilopascals.